Welcome to another video of QOTD, and today we'll be continuing on further mathematics for A level, of course, and we're going to continue on matrices. And today we're going to talk about multiplication of matrices, and we're going to only be talking about the basics for today because we're going to go much deeper later on in future lessons. So let's get started. And as we've learned previously in the first lesson, a matrix consists of rows and columns. And as you can see here, we got a 2 by 2 matrix. And very simply, how we present a matrix multiplication, we first need a 1 by n and a n by 1 matrix. So let me put in simple terms, 1 by 2 and 2 by 1. 3, that's a square bracket, never do it like I did. And let's do 1, 0 just for now. And we're multiplying these matrices together. And remember, this only works for 1 by n and n by 1 matrices. I mean, it will be more enhanced later on in the lesson, but then we'll keep it simple for now. So when you do the multiplication for these matrices, you first do the first element of each of the matrix and then the second element of each of the matrix multiplied together, and then we want the sum of them. So 2 multiplied by 1 plus 3 multiplied by 0, that gives us 2. So that will be a matrix of 1 by 1 size that consists of the element 2. And we can elaborate on this a bit. So perhaps we can have a bigger matrix for the first one. That's 3, 2, 1, 0 multiplied by 1, 2 perhaps. And what would that give us? Well, it won't give us a 1 element matrix. Instead, it will give us 2. Because this time, if you observe carefully, the first matrix consists of 2 rows. And therefore, we will have to do the same calculation above 2 times in order to receive 2 values. And let's do the first row, 2 times 1 plus 3 times 2, that will just give us 8. So that's 8 on top. And 1 times 1 and 2 times 0, that will just give us 1. And you might have noticed the pattern already. It's a 2 by 2 and a, that's multiply, so I'm going to put a bracket, multiplied by a 1, a 2 by 1. You say the row first. And as you can see, the numbers next to each other are the same. And this is the exact algorithm we have to follow when multiplying matrices. When we have m multiplied by n, that's the size of the matrix of the first one, and n by j. I'll keep it lowercase so it doesn't confuse. And as we can see, the column of the first matrix and the second matrix row have to be the same number in order for them to be conformable to multiply each other. And that is what we call conformity in matrix multiplication. You have to have the same number of row for the first matrix and the same number of column for the second matrix, or vice versa, in order for them to be able to multiply each other in this way. And let's look at another one. We're going to talk about this is not really in the lesson I've planned for today, but then I can tell you guys anyways. So remember the index matrices we talked about yesterday, which is 1 diagonally. When you multiply these index matrices by any matrix in general that is conformable of multiplying, it will always give itself as a resulting matrix, which is really interesting. But if you think about it, 1, 0, 0 and 1, 0, 1, that will just give us 1 for here, which is 1, and then 0, 1, 0 multiplied by 1, 0, 1. 0, 1, 1, 0, 0, 1. So it gives us nothing. 0, 0, 1, and that leaves us with a 1. It's really interesting. And you can try to prove this yourself after the lesson in the comments. I hope to see some really good ones there. And then the last one we're going to talk about is associativity and commutativity. As we learned previously in the lesson, associativity and commutativity also works for matrix multiplications. I think we talked about it yesterday, so I'm not going to go deeper into that. And the last thing is, oh yes, when a matrix multiplies by itself, we can use the power notation. So if A equals to 1, 2, 2, 3, 1, 3, 2, 3, okay, and when we do a multiplication, we can simply do 1, 2, 3, 3 to the power of 2, like we did before, previously in your primary or secondary school. You can just do the same for matrices. And that's all for today. Hope you learned something, and hope to see you next lesson.